So our whole purpose behind actually finding your possible zeros are so you can find all the actual zeros, okay? So whenever you have a polynomial like this, it can't be factored. You can't just like factor it and using a normal method that you know, like grouping doesn't work, nothing like that. So what we need to do is we need to figure out one of our solutions so we can reduce this polynomial down and then maybe have something that can be factored. Well, to find one of our solutions, we're going to have to guess a little bit. Okay, well, you don't want to just shot in the dark guess and say, well, I think it's 5, I think it's 7, I think it's, you want to make a good guess. So the way we make a good guess is by listing all those possible solutions like you just did, and then picking one of them to try. And you are going to have to check and guess and check for this. Okay, you're going to have to do, there are some error things that happen here until you find the right one. Okay, so looking down here, let's just work a problem. Okay, question number 1. Again, you can try to factor this, but that's not going to, it just doesn't work. Okay, there's nothing, I can't group this. I could take an x squared out, but here there's nothing I can really take out of those. So I'm going to have to guess and check. Well, again, to guess and check, you're going to have to list out all the possible zeros. So coefficient here is 1. That means our q, I'm going to write it up here so I'm sure I have plenty of room, is plus or minus 1. Our p are all the possible solutions to 28. So that's 1, that's 2, that's 4, that's 7, that's 14, and that's 28. Okay? So we just need to pick one, use synthetic division to see if it works. If you don't have a remainder, you found one of your solutions, and you can go from there. Okay, so I'm going to take a guess here, and personally, I like to guess 1 to start. Okay, 1 is a nice easy one to plug in. 1, 4, negative 25, negative 28. Okay, I think 1 is one of my solutions. When you do this, you're going to bring down the 1 and do your synthetic division. So 1 times 1 is 1, that's a 5. 5 times 1 is 5, that's a negative 20. Negative 20 times 1 is negative 20. That is not going to have a remainder of 0, so 1 is not one of my solutions. You see how terrible this could get, okay? So good thing we have just a few possibilities to pick from. So I'm going to try negative 1 next. Sometimes it's a little more obvious what's going to happen. I'm pretty sure negative 1's not going to work too well either. That's negative 1, that's 3, that's negative 3. Uh-oh, this is looking actually pretty good. Negative 28, negative 28 times negative 1 is a positive 28. That is 0. So I have found one of my solutions. Negative 1 is a solution to this polynomial. Okay, to find the other ones, all you have to do is plug your x's back in, and then you have something that can be factored. Okay. What multiplies, so first of all, plus minus is a plus minus. What multiplies to be 28 and subtracts to be 3? That's 7 and 4. So what are your solutions? X equals negative 7, x equals 4, and x equals negative 1 from our solution that worked. Okay. That means when we were guessing and checking, if we had picked 4 for our next number, we plugged 4 in, and it would have worked 2, we would have been able to reduce that one down also and factor afterwards. So you see how this can be a little time consuming and tedious just depending on how big your polynomial is. Kind of like the next one. This is a degree of 4, so a lot going on here. And good news is all my q values is still just plus or minus 1. P values, there's a lot here, 1 and 2 and 3 and 4 and 5 and 6 and 10 and 15 and oh, I skipped one, 12 and 30, nope, 20 first, 30 and 60. Gross. Sorry that got so crazy. But I just got to pick one. Okay, pick one to try. Let's try 1 again. Again, I'm a big fan of starting with 1. Put your coefficients across there. That's a 1. That's a 2. That's a negative 11. That's an 8. That's a negative 60. Bring down the 1. 1 times 1 is 1. That's 3. That's 3. Negative 11 and 3 is a negative 8. Yeah, I had a moment there. Negative 8, that's negative 8. That's 0, that's 0. That is a remainder of negative 60, so no way. Okay, let's try negative 1. 1, 2, negative 11, 8, negative 60. Bring down the 1. Negative 1, 1, negative 1, negative 12, positive 12, 20, negative 20. Also doesn't work. Okay, so yeah, let's try something else. What about like 2? 2. I can see that you're probably getting a little disheartened here. Don't give up, okay? You can totally do this. 1 times 2 is 2. That is 4. That is 8. That is negative 3. That is negative 6. That is 2. 2 times 2 is 4. So also doesn't work. One thing that I like to do sometimes, and this is only if you can keep up with it, sometimes when I get to something like this, I like to say, okay, well, what if this had been a negative 2? Can I just make my changes here? Well, 1 times negative 2 is negative 2. That makes that a 0. 0 times negative 2 is 0. That makes that a negative 11. That makes that a positive 22. That makes that a 30. 30 times negative 2 is a negative 60. So close, but no good unless I messed up on my sign somewhere. Nope. All right, that's okay. Don't give up. Let's try another one. Like, what about negative 3? I used to work this out ahead of time, and I already knew a good answer to guess. But this is legitimate. This is seriously how you may have to work these. You have nowhere else to start. You should be thankful that, and I don't know why I chose negative 3. Negative 3 seemed like a good number. You have to be glad that at least you have something to guess with to start, okay? That's negative 33. That is a positive 99. There's no way that that's going to work either. So what if it was a positive 3? That's a positive 3. That's a 5. That's a 15. 11. That is a 4. 4 times 3 is 12. That is, I'm feeling good about this, 20. 20 times 3 is 60. So yay, that worked. 60 worked. 3, positive 3, is one of my solutions. Again, from there, you plug your x's back in. So I'm going to come over here to do that because, of course, I've ran out of room. Remember, you start with 1 less. So our original equation was an x to the 4th. So I'm going to start with an x to the 3rd. X to the 3rd plus 5x squared plus 4x plus 20. That is my reduced polynomial. Okay, so again, I know 3 is one of my solutions. I need to find my other. Now, great news here is this polynomial can be factored. Okay, it is very possible that once you find one of these solutions, this is still not nice to factor. Very possible. Good news, this one is. So again, I can do grouping here. If I take out the x squared, that leaves me with an x plus 5. If I take out the 4, that leaves me with an x plus 5. So that leaves my solution, or my factors here, x squared plus 4 times x plus 5. Okay. I can find my solutions from here. So this one's easy. X equals negative 5. I already knew x equals positive 3. This is the tricky one. Please don't tell me that that factors to be x plus 2 and x minus 2. It would, except for this plus sign here. So that cannot factor that way. What you can do, though, is you can take x squared plus 4, set it equal to 0, and solve. When you do that, you subtract the 4. It gives you x squared equals negative 4. When you take your square root, now this is going to throw you back a little, square root of negative 4 equals, x is plus or minus 2i. Remember, the square root of a negative is an I. So these are actually your 4 solutions. Again, if this is an x to the 4th to start with, I should have 4 solutions. I have 3, I have negative 5, I have positive 2i, and I have negative 2i.